Good day, grade 8 learners. In this video lesson, you're going to learn about the physical changes in solid, liquid, and gas. And the most essential learning competency, explain the physical changes in terms of the arrangement and motion of atoms and molecules. We have the following specific objectives. At the end of this video lesson, you are expected to, first, enumerate the processes involved in physical changes. Second, explain the process involved in physical changes in terms of the arrangement and motion of atoms and molecules in a material. And last, you have to draw or illustrate the arrangement and motion of atoms and molecules in a material as it undergoes physical change. But before we proceed, let's have first a recall of what you have learned in the previous video lesson. In the previous video lesson, you have learned that matter is anything that has mass and volume. Matter is made up of tiny particles called atoms, moving with spaces between them. Atoms are the smallest particle of matter, and molecules are atoms banded together. Solids, liquids, and gases varies in terms of the arrangement and motion of particles. You also now have a clear picture of how the particles are arranged in the three states of matter: solid, liquid, and gas. These ideas are some of the features of what scientists call the particle model of matter. Series of activities will help you understand physical changes in terms of the arrangement and motion of atoms and molecules in a material. Now, for recall, activity number 1 entitled All About Physical Change, you have to read each statement and you have to put a check mark if it describes physical change and an X mark if it does not. The conversion of ice to water or water to ice is a very usual occurrence. Changes like this, which do not alter the composition of a material, is called physical change. Words like melt, boil, freeze, dissolve, evaporate, condense, and sublime indicate a physical change. Other term includes cut, bend, crack, crush, and grind. While changes which involves changes in the composition of a material is called chemical change. Food undergoes chemical change as it is cooked. Burning and rusting also involve chemical changes. Words like cook, bake, decompose, combine, corrode, decay, grow, rust, spoil, and ferment usually signify the occurrence of a chemical change. Now, for the next activity entitled Exploring the Different Processes Involving Physical or Phase Change, you're given the task to identify the phase change being referred to by the given description and examples. Remember that phase change typically occur when the temperature and pressure of a system is altered. This is the result when there is an increase or decrease in the amount of thermal energy contained in the system after heat transfer. Melting, freezing, boiling, evaporation, condensation, sublimation, and deposition are examples of physical change. These commonly result in changes of state or phase. Notice that changes of state are reversible. For example, a liquid substance changes to solid during freezing. It changes back to liquid during melting. But the essential question would be, what causes a substance to change its state? This can be explained using the kinetic particle theory, which states that the particles of matter are in constant motion, meaning atoms and molecules are always moving. If heat is added to a substance such as in melting, vaporization, and sublimation, the process is endothermic. As a result, heat is increasing the speed of the molecules, causing the particles to move faster. However, if heat is removed from a substance, such as in freezing and condensation, then the process is exothermic. As a result, heat is decreasing the speed of the molecules, causing them to move slower. These changes release heat to the surroundings. In short, relationship between temperature and the kinetic energy of particles is directly proportional. As the one increases, the other factor also increases. On the other hand, as the one decreases, the other factor also decreases. But remember that the amount of heat needed to change a sample from solid to liquid would be the same to reverse the liquid to solid. The only difference is the direction of the heat transfer. Now, let's talk about each phase change. When a substance changes from liquid to gas as it is heated, it is called evaporation. Evaporation occurs when some particles on the surface of the liquid have acquired enough energy to break away from the attraction to the other particle and escape as gas. Condensation, on the other hand, occurs when a gas changes into liquid as it cools. When water vapor touches the surface of a cold bottle, the particle loses energy and moves slowly. Eventually, the particles move slow enough, thereby increasing the attractive forces between them. As a result, gas turns to liquid. Next is melting. It occurs when a solid turns into a liquid as it absorbs heat. When a solid is heated, heat energy is absorbed by the particles. Heat energy is converted to kinetic energy, and the particles vibrate and rotate faster on their fixed position. Eventually, when the energy is sufficient enough to overcome the strong forces of attraction between the particles, they break away from their fixed position. Particles now slide over one another in the liquid state. Next is freezing. It occurs when a liquid turns into solid, as its temperature is lowered by its freezing point. A liquid is freezing when the heat energy of the particle is given off. As a result, the particle loses kinetic energy and begin to move slowly. As the temperature decreases, the particles can vibrate only in their fixed position in the solid substance. Next is sublimation. This is a phase change which occurs when a solid transforms into gas without passing through the liquid phase. Here is an example. This is a dry ice. When particles at the surface of a solid acquire enough energy to break away from the force of attraction in the solid, they escape as gas. Last is deposition. This occurs when a gas transforms into solid without passing through the liquid phase. This is the reverse of sublimation. You can now proceed with activity number 3 entitled Explaining the Processes Involved in Physical Changes in Terms of the Arrangement and Motion of Atoms and Molecules. You are given the task to describe the arrangement and motion of atoms and molecules in the different processes of phase change before and after the change occurred. To give you an example, for the first material, ice cream, during melting, before the change, the particles in ice cream are tightly close together and do not move past each other. In solid, the particles vibrate in place. After the change, after the ice cream has melted, it turns to liquid. Particles are quite close together and move with random motion throughout the container. For the next activity, activity number 4 entitled Graph Analysis, you have to analyze the graph of temperature of ice turning to liquid and complete the statements that follow. There are 3 questions for you to answer. Question number 1 is equivalent to 1 point, and question number 2 and 3 is equivalent to 2 points each. And for the last part, evaluation, you're given the task to show the arrangement and motion of atoms and molecules of water as it undergoes various physical changes through illustration, model, drawing, or others. This will be the scoring rubric that will be used. There are 2 criteria: details and creativity. Now, to wrap things up, in this video lesson, you have learned that phase change is the change from one state of matter to another. And there are 6 phase changes. We have melting, which is the change from solid to liquid; freezing, which is the change from liquid to solid; evaporation, from liquid to gas; condensation, from gas to liquid; deposition, from gas to solid without passing through the liquid phase; and sublimation, which is a change from solid to gas without passing through the liquid phase.